Hi everyone, my name is Kunal Batra. I'm a Senior Technical Evangelist here at AWS, and this is AWS Reinforce, our first security conference. So let's get started. I'm joined by two of my guests here, Tom and Tom. Tom Plevel, Tom Adamski?
Adamski, yeah.
Nice. And just before we get started, I want to just mention a quote, one of my favorite quotes, which this session kind of is on, and it's from Werner. Dance like nobody's watching, encrypt like everyone is watching. So this session is on encryption and also securely accessing your services from anywhere. So why don't we get started talking about high level, how do we do that, a little bit about VPN and everything else.
Okay.
Absolutely.
You want to kick off?
Whoever wants to go.
Yeah, so we have two types of VPN, managed VPN solutions.
Okay.
For connecting to your resources in AWS, but also connecting to your resources in AWS and then going elsewhere.
Got it.
Potentially over direct connect back to on-premise or connecting out to the internet.
Got it.
And the two types of managed VPN solutions we have is AWS managed site-to-site VPN. So this is pretty much where you have a network environment on one side. This could be your on-premise data center. This could be your branch.
Right.
And you're connecting that to an AWS environment, a VPC, multiple VPCs, and then you're allowing for communication between those environments. So you might have applications in your data center. You might have applications on AWS, and then you allow for communications between them.
Got it.
That's encrypted, going over the encrypted IPsec tunnel.
Okay.
And then the second type of VPN connections we have, they're AWS client VPN, which is a remote access VPN. I guess many of you that use VPN for your office, you'll be familiar with remote client solutions.
Right.
That's where you're maybe sitting in an internet cafe somewhere and you're connecting to the resources on AWS.
Yes.
I would like to add that the role of encryption is really to protect information from a third-party acquisition. So at AWS, we like to keep the data on the network where it's going to be isolated. And we also like to build interfaces and connectivity between different resources within that network so that it is secure. But there are times when the data can be accessed by third party because it has to be shared on the internet, and that's when you need encryption. Or because you are going to share the data with a third party that needs to have access to that data, and you don't know what's going on in that third party's deployment. So you also need to encrypt the data to make sure that only that person is going to receive the data.
Got it.
Yep.
Makes sense. So two things you mentioned so far, for VPN specifically, site-to-site and client VPN. We defined them. I'm just curious, now for site-to-site, it sounds like there's more throughput happening in this than perhaps a client VPN connection. Do you know what the limits are for throughput? Just curious for site-to-site.
Yeah, so it depends also when you're landing your site-to-site VPN. So you have two options today. You can land your site-to-site VPN directly on a VPC through the virtual private gateway, VGW.
Okay.
Or you can land it on the transit gateway, which we announced late last year.
Okay.
And transit gateway allows you to connect to thousands of VPCs in the region. So this way you can set up a single VPN tunnel and get to thousands of VPCs.
Got it.
And those VPN tunnels, depending on what they land on, will have different performance parameters. So if you're landing on a VPC or on a virtual private gateway, a single tunnel, you'll be able to get 1.25 gigabits a second.
Okay.
But what you can't do is you can't start using multiple tunnels. So even if you add 4 tunnels or 2 tunnels, you can't use multiple tunnels to get additional bandwidth from AWS back to on-premise.
Got it.
But if you land your VPN on the transit gateway, that's where you can start doing, we call it equal cost multipath. So effectively allowing you to create multiple tunnels, multiple connections, and start distributing the traffic across them to get additional bandwidth.
Got it.
So you still have a 1.25 gigabits second maximum per single tunnel, but you can multiply those and have tens of gigs of capacity going over VPN to the transit gateway and then to your VPCs.
Got it. And just for the viewers, you mentioned two items here, transit gateway and virtual private gateway. Can you just talk a little bit about what the difference is and what they are?
Yeah, so virtual private gateway is the more traditional construct. It's been with us for a while, and you would have a virtual private gateway or VPN gateway or VGW, we have multiple names for it. You'd attach it to a single VPC,
okay,
and then you would use it as an exit and entry point to and from on-premise.
Okay.
So it's purely used for connectivity back to on-premise, either over the VPN or over Direct Connect. which is a dedicated physical connectivity to AWS.
Got it.
With a transit gateway, you can start attaching multiple VPCs to your transit gateway. So you can now have traffic going between those VPCs through the transit gateway, and you can have thousands of VPCs connected to a single transit gateway in a region. And I know we always say, we always talk about different types of gateways, and a lot of people might be thinking, oh my God, is it a single point of failure?
Right.
It looks like a single object when I draw it on my diagram. It's actually a distributed system of multiple devices. So even though it looks like a single router, it's never a single device. It's a distributed system that we use to allow for communication between multiple VPCs.
Got it. Sounds good. So you mentioned the differences between both of the gateways. How would you recommend, how should they go about designing their VPCs? What type of gateway should they use?
Yeah, so if they have a small number of VPCs, and they're planning to interconnect them together or connect them back to on-premise, that's where you might just use VPNs going straight to the VPCs, or you might use another construct called VPC peering.
Okay.
And VPC peering is used purely for connecting one VPC to the other, but it's a one-to-one relationship. So if you have like 3 VPCs, you want to connect them all together, you would have each VPC peer to another VPC, and then you might configure your tunnels going back to on-premise. But once that starts to scale, it can get quite cumbersome and complicated to be managing all those different VPN connections. If you have 100 VPCs, you have 100 VPN connections going back to on-premise.
Got it.
So that means 100 configurations on your on-premise environment. Same with the peering. Once you get over a certain limit of VPCs, you're going to hit a limit of peering connections you can have per VPC, and that's 125. So once you go above a certain scale, probably a few VPCs, 10 VPCs, you might start looking at deploying the transit gateway to do 2 things: help you interconnect VPCs inside a region, but also help you consolidate connectivity from those VPCs back to on-premise, either using VPN, or you also have the option to use Direct Connect.
Nice. Tom, now, the other Tom, are there any other methods, now we talked about encryption, any other methods for securely accessing services either, or just VPN, site-to-site, or client VPN are the 2 different
So you have multiple ways to access those services. VPN is just one of them. And you can definitely build up direct connections, for instance, to access your services so that your physical network, your on-premises network, is directly connected to your network in the cloud, your AWS network.
Got it. And how would a customer go about doing that?
I'm sorry?
How would a customer go about doing that, creating that direct connection?
To create the network, to create the direct connection?
Yes.
So you basically work with AWS to create the direct connection.
Got it.
And we're going to provide you with that connection based on your locale. We're working with different partners who are connected directly to AWS through the fiber optic channels.
Awesome.
Yeah, so I can add to that. So you effectively can go into the console as a customer and pick the location you want to use to connect to AWS. And we have 95 plus locations all around the world. So the recommendation is to pick the one that's closest to where you are, where your data center is. So it doesn't matter where your resources really live. So you could have resources in US, but maybe your data center is in Europe. Then ideally you probably want to pick a direct connect location that's closest to your data center. So then you can use the AWS uncongested backbone to get your traffic from that direct connect location to any region of your choice.
Got it. That makes sense.
One thing I want to expand on this, because we're talking about the connection with the user and with the sites, but we also have to think about the connection in the cloud and the termination of that TLS encryption. I think nowadays a lot of people are terminating the TLS encryption in the instance, and so they're using a lot of resources for that. And it's very compute heavy to decrypt the information that you have encrypted. What we do now is we enable TLS, what we call TLS termination, the decryption of TLS encrypted information. So we enable TLS termination on the NLB level. The network load balancer can be offloaded with that task so that you're going to save your compute resources for other tasks in your network.
Yeah, that's actually a good point, because if you have your applications maybe sitting behind an application load balancer, You don't have to run TLS termination on your end resources, on your instances. You can do the TLS termination, as Tom mentioned, on the actual application load balancer, and then offload that from your instances, and also have us, AWS, manage your encryption ciphers and all of the management that goes behind terminating TLS. But on top of that, with application load balancer, if we're talking about accessing applications, you can also do pre-authentication. So you can use the application load balancer integrated with our authentication service Cognito that can integrate with your own identity provider. Maybe you're using your on-premise identity that is SAML enabled. You can integrate that with application load balancer. So if someone's connecting to your application from the internet, so not over the VPN, they're just going from the internet, you can still validate and authenticate that user on the application load balancer before you allow the traffic any further to go to the actual application.
What was the name of the application you said? Nico?
Application load balancer.
Application load balancer. And then if I want to connect to my own IAM or something else to do the IAM?
Yeah, SAML is the standard.
SAML, okay,
so it integrates with Cognito. It's our authentication service. And then Cognito then can authenticate with a variety of different identity stores, including you can create your own identity store, so manage your own users in Cognito itself.
Perfect. And now everything here can be done through the console, right?
Yeah, you can do everything for the console. You can also do everything through the CLI or just use API calls if you're into automating things.
Nice. Which is one of the themes here for Reinforce, right? The more automation, the better.
Absolutely.
Great. Before we get into I guess you have some slides and demos, are there any other topics you want to cover before we kind of go into that, or should we break right into the slides and demos?
No, I think we've covered pretty much everything at a high level. If we can take a look deeper into the features, that'd be great.
All right. Okay, there we go. So I have a demo environment set up in my account. And this is what we have at the moment. So I have a VPC in AWS, that's the thing on the left. I have 2 subnets in different availability zones. I have an instance in one of those subnets, and I also have an internet gateway. Internet gateway is effectively a way for that instance to be able to get out to the internet. And then I have our remote locations, remote users, that we want to connect to that VPC. So we'll look at the 2 different VPN options we have. We'll look at the AWS site-to-site VPN, and we'll look at the client VPN. So for the site-to-site VPN, in the demo, I've terminated that VPN on the transit gateway. Instead of directly on the VPC, I had an option to do it on the VPC, but I prefer to do it on the transit gateway because I might have additional VPCs connected to that transit gateway in the future, so it's much easier for me to manage a single tunnel instead of hundreds of tunnels to multiple VPCs.
Got it.
We'll also look into using AWS Client VPN to connect that user to the Client VPN endpoint first, and then to the VPC. And that's the thing I'm going to demonstrate. So that VPN user is going to be able to connect not only to the instance inside the VPC, but also that user will be able to use the established site-to-site VPN back to on-premise data center to reach that server instance in that data center. And then finally, the user should also be able to go out to the internet if we are willing to allow that. Yeah, and here is the optional additional 5,000 VPCs that could potentially be hanging off that transit gateway that now have access to the corporate data center or can be accessed from that user. Okay. I'll just get into the meat of it. So I'll show you first a quick setup of how the VPN is actually configured. So I have it running in Ohio. If we look at the site-to-site VPN connections, I have my reinforced demo connection here. You can see if the VPN is actually going from the virtual private gateway,
right,
or is it going from the transit gateway. And we actually provide you with a very easy way of moving your VPNs around. So if you started with your VPN connecting to the private gateway, and then you added your transit gateway, and you want to move that VPN connection, you can just go into the configuration here, modify VPN configuration, and say, actually, I want this to terminate somewhere else.
Right.
And we'll take care of moving that connection to the other side. But we're connected to the transit gateway, so that's perfect. So that's that VPN back to on-premise. I've also configured a client VPN. So this is now me as a user on my machine. I'm going to try and VPN into the VPC, and from there, connect to the instance I have in that VPC, and then connect back to that on-premise server.
Nice.
So let's have a look first. What's the IP address of the instance? So I know what am I actually trying to ping. And we'll use just basic ICMP to confirm connectivity. So let's have a look here. We have an instance, and its private IP address is in the 10.123 subnet 1.80. Perfect. So when you configure your client VPN, you actually have the option to download the client configuration. So let me show you how that looks like. In here, I can download the client configuration. I've already done that. I'm using an OpenVPN capable software for setting up the VPN. So I can open that. So it's called Tunnelblick. So in here, this is my reinforced VPN client. You can see I've tried it before, and it worked. Hopefully, it's going to work again.
Nice.
So I'm going to open my console as well, and I will try to ping. Let's clear that. I will try to ping the on-premise server first, and that shouldn't work. And then I will try to ping that 10.123. What was the IP address again? My instance, 1.80.
There we go.
Yep, that's also not working. No, still haven't set up the VPN. It looks deceitful. It looks like it's happening.
Like it did. Yeah, it did.
Yeah, but it's actually failed. Okay, so let's configure the VPN. We were here. Let's set up the connection. Connect. And I'm using, there's two types of authentication for where you're connecting to a client VPN. You can use Active Directory, or you can use client certificates. In my scenario, I'm just using client certificates, keeping it simple. So the VPN connection is now up and running. It's connected. If I go into the console, I can actually have a look who's connecting to my VPN. So let's go and check it out in connections. You can see here that I've just connected. I'm client 1. I've got an IP address. So now I should be able to start connecting to the things I weren't able to connect before. So there we go. I can reach the instance inside a VPC. And then let's see if I can get back on premise to that 192 address. Yep, that works as well.
Now, is the internet gateway connected as well? Can you?
The internet gateway is connected as well, but it's mostly used for me to be able to access the EC2 instance.
Got it. Okay.
So it hasn't been used for any of the connectivity we showed a minute ago.
Okay, got it. Makes sense.
And I see we still have some time. So if we have some time, I can show one other thing that's actually quite cool.
Let's go for it.
Yeah, awesome. It's probably one of the less known services, Session Manager, Systems Manager. It's another remote connectivity option for when you want to access your resources.
Right.
So in here, there's a Session Manager service. It allows you to access your EC2 instance without you having to create keys or setting up any SSH configuration. And it will use the IAM credentials to let me SSH into my Linux instance I'm running.
And this happens on the console?
It happens in the console. It happens in the browser. So I have to update the SSM agent.
That's a great little hidden feature for our audience watching. Not many people know about that. I found out about this pretty late.
Yeah,
really,
it's a great gem. So for any events, for any training sessions we do with customers, this is awesome. It's absolutely great. So I'm updating the agent. I'm actually using the run command. So the systems manager is managing my instance, so I can update the instance without having to log into it. And now I can go back to Session Manager. The agent is up to date, so I can now start a session to my instance. And voila, in the browser. If my connection can establish. There we go.
There you go.
So we can see that this is the instance that we're playing with, the 1.80.
Right.
And we can, from here, we can also test if our VPN connection back to on-premise works, right? So we can ping that on-premise server over the site-to-site VPN.
Very cool. That was awesome. Looks like we're running out of time as well, so this is perfect. Thank you so much, guys. And I hope everyone else in the audience appreciated that. Thanks, guys.
Thank
Take
you.
care.
Thank you.